Hi, Linda. We are going to find the surface area of this shape when you revolve it around the y-axis. And for that, you're going to need this formula. So this is just something that comes to us from Calculus 2. The surface area is x times this square root thingy. The square root thingy is the arc length. So x represents the radius. You don't really need to know why it works the way it works, but it does. So that's the formula. So we need f prime. So the formula involves a derivative. So I think you know how to take the derivative of this. It's the power rule. It's negative 6x. And what I like to do is just kind of set everything up first. So f prime squared is negative 6x squared, which is 36x squared. Okay, and we are in particular going from 0 to 1. So we want the integral from 0 to 1 of x times the square root of 1 plus 36x squared. Sometimes these can be very difficult to evaluate, but this one shouldn't be too bad. So if you look at it, we have an inner function of 1 plus 36x squared and like a function, outer function flow now here of x. So we want to do a u substitution. So if we let u equal 1 plus 36x squared, du is, what's 36 times 2? 72? 72x dx. And that means that 1/72th du is x dx. And then what I'd like to do with these two is actually change the bounds of integration. So x is going from 0 to 1, but if we just rewrite everything in terms of u, we don't have to worry about x anymore, and we don't have to switch it back to x because this is a definite integral. So when x is 0, u is 1 plus 36 0 squared, which is 1. And we say when x is 1, u is 1 plus 36 times 1 squared, which is 1 plus 36, which is 37. And these are the kind of weird numbers you're going to get when you start doing surface area integrals. You're going to get numbers like 37 and then the square root of them as well. So now we can write this entire integral in terms of u instead of x, and it should be pretty easy to compute. So instead of going from 0 to 1, we're going from 1 to 37. Our x dx becomes 1/72, 1 over 72. And since u is 1 plus 36x squared, this whole thing just becomes the square root of u, du. There's our du. Okay, and now it's computable. So I have a feeling that was probably what you had a question about, but in the interest of thoroughness, let's just complete it. So we're going to do 1 over 72. I always like to bring those constants to the outside, times the integral from 1 to 37 of u to the 1/2. And I also always like to write things like square roots as rational exponents. So that's 1/72 times power rule for integrals. Power goes up by 1, and you divide by the same number, which is the same thing as multiplying by the reciprocal. So this is going to go up to 3/2, which means we have to multiply by a 2/3. Dividing by 3/2 is the same as multiplying by 2/3. And that is going from 37 to 1. And that's what I mean when I say you're just going to get some weird kind of numbers in here. Weird fractions and weird roots. So let's see, 1/72 times 2/3. Can you tell I didn't actually do this problem first? 36 times 3 is 108, of all things. And then you're just going to do, 37 to the 3/2 minus 1 to the 3/2. And 37 to the 3/2 is just some weird irrational number. So there's no reason not to just leave it like that. And 1 to the 3/2 is just 1 because 1 to the anything actually is just 1. So if you have to leave that as a decimal for the particular problem, then just go ahead and punch that in your calculator because who knows what it is. But that's the exact answer. It's 1 over 108 times 37 to the 3/2 minus 1. Okay, fun one. Thank you.